Hey guys and gals, right, video today then is a brand new topic that we're going to try and work on this week. I'm going to try and lay the foundation, and I think it might be Mr. Warnes that does a live lesson on it in the future. So we're going to start you off with probability now. That's a huge area of maths, really, really important. It affects everything in real life. Essentially, life's a game with many different odds. So we're going to start off with Hegarty video 351 today, which is very simply the probability of single events. This should be very, very simple stuff for you to get your head around, I hope. But again, making sure that we cover the basics of this for you whilst you're at home is really, really important. So there's some important keywords to sort of get a head round at first. An event. If we talk in probability terms about an event, then it's something, an experiment or some element of life that we are interested in the probability of. If we talk about an outcome, we are looking at one of the outcomes of that event. If you roll a dice, there are 6 outcomes, 1, 2, 3, 4, 5, 6, assuming it's a fair dice. Fair, well, that's something that we're going to come up with in a bit. It means everything it's equally likely. We have sample spaces, which is a posh way of just saying what's all the outcomes, list them, show them me. And what we're going to talk about today, particularly, is theoretical probability. So this is all exactly as it should be. And obviously, life doesn't go exactly as it should be. So these are strictly mathematically theoretical. And what we're going to look at first is probability, which we generally, from here on out, refer to as P, because we're lazy and we don't want to write probability every single time. So the probability of an event, any event, is the number of desired outcomes that you want. So number of desired outcomes over total number of outcomes. And that's it, really. That is the theoretical probability. If you roll a dice, as we've already mentioned, if we wanted, this is a classic one here, if you've played a lot of board games as a kid, the probability of a 6, notice how I've written it, so P for probability, and then the outcome that we're interested in, we put in there. So the probability of a 6 is equal to, well, how many 6s are there on a fair dice? Number of desired outcomes, there is just one. And over the total number of outcomes on a fair dice, 1, 2, 3, 4, 5, 6, there are 6 outcomes. So the probability of a 6 is 1 out of 6. This can be hard for people to get their head around, particularly because we have something called confirmation bias. So if you've played board games as a kid, particularly Frustration was one that stuck in my mind, where you're not allowed to start until you roll a 6, or Monopoly, where you can roll a double to get out of jail, or a 6 is obviously better because you get to move more squares. It can give us this confirmation bias that a 6 is harder to roll than other outcomes on the dice, which of course is crazy. If it's a fair dice, they are all equally likely, and that's a really important term to consider. So let's look at some of the questions that you'll be getting then on Hegarty. A fair spinner, they love their spinners, shown in the diagram above, is spun. Work out the probability of getting a 5. Give your answer as a fraction in its simplest form. So there's 2 things to note here. One is the answer, because it's very easy. Probability of a 5 on this particular spinner, well, there's clearly 5 outcomes there. 1, 2, 3, 4, 5. Only one of them is a 5, so the probability is 1/5. Now, frustratingly on Hegarty, you're going to get this line here quite a lot. Give your answer as a fraction in its simplest form. On exams, they never really do say that. They never care about you simplifying it, and quite honestly, I don't. As it can be incredibly frustrating when we get to the harder, more difficult areas and elements of probability. It can actually be quite beneficial to not simplify your answer, as you may need to add probabilities together, and if they've already got the common denominator, some will simplify, some won't, so you can end up giving yourself more to do later on. Let's fire through this. We're talking, there you go, so fair dice is rolled, probability of getting a 3, well, there you go, it's just the same. There is only one 3 out of 6. Should be fairly simple. Does it give us anything? Work out the probability of getting more than 2. Probability of more than, there's the inequality symbol, 2, on a fair dice. Well, again, there's still 6 outcomes on that fair dice. More than 2. Be very careful on that. Not more than or equal to, more than. That means 3, 4, 5, 6. 4 outcomes. So the answer is 4/6. Now in a classroom, I'm perfectly content with that answer. Just be aware that Hegarty is asking for you to give your answer in its simplest form. So you are going to have to practice your simplifying fractions. Divide top and bottom by 2 in this case, 2/3. What else is it giving us? You are going to have to get comfortable with a deck of cards. The video does have a picture of a deck of cards. If you're unfamiliar with decks of cards, try and relate it to the year. There's 52 cards in a deck, just like 52 weeks in a year. There are 4 suits in a deck of cards, just like there's 4 seasons in a year. Half the deck is red, half the deck is black. You really do need to familiarize yourself. We're in lockdown. You've got plenty of time to play cards with whoever's available. You've got your hearts and your diamonds, which are your red suits, and you've got your spades and your clubs, which are your black suits. Because you will get, inevitably, you will get questions on decks of cards. Unfortunately, examiners haven't really moved forward into 2020. They're not going to be asking you questions about Minecraft and probability of drops on Fortnite. They're going to be asking you questions about decks of cards and assuming that you're all still playing Snap and stuff. So a single card's drawn from a standard 52 card deck. Work out the probability of choosing a spade. So the probability of a spade. Now we can go for the very, very long-winded one here. It tells us there is 52 cards in the deck, and we can literally go, and I'll say this now because it's worth it. On a maths question, it is always assumed that the ace is low. So if you do play card games, sometimes ace is high. In mathematical world, ace is always low. So ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you have what we call our face cards, Jack, Queen, King. So you've got 13 cards in each suit, so there will be 13 spades. However, give your answer in its simplest form. Think about what I've just said. There are 4 suits, and spades are one of them. So we can go straight to 1/4. What else have you got for us, Hegarty? Factors. You can, particularly with the dice question, they can ask you questions like, what's the probability of getting a factor of 2 or a multiple of 2? You may get primes. Do we have that one? They've not given it here, so they can ask you what's the probability of rolling a prime number. I will give you the heads up now. 1 is not a prime number. Don't do that to me. And that's it. That's video 351. Should be very, very simple for you. I'm going to reach across my screen here and load up 352 as we go. And it's similar stuff, but not necessarily all with dice and pre-made spinners. So let's look at question 1. We're going to go for the same outcomes here. So there is a bag with only red and blue marbles. The probability of randomly choosing a red marble is 1/8. So I'm going to just write that down. The probability of red is 1/8. Well, if there's only red and blue marbles, then straight away, it's not asked me yet, but I'm thinking the probability of a blue marble has got to be 7/8 because all probability has to add up to 1. 7/8 add 1/8 is 1. There can't be anything left over. The question is actually asking us, I didn't need that, by the way, that's just my mind working overtime. There are 72 marbles in total in the bag, and each is equally likely to be chosen. They have to be really careful with their wording, okay? Equally likely is important here. If the probability of a red marble is 1/8, then that means 1/8 of all the marbles in there are red. So if there's 72 marbles, we're saying that the number of red marbles is 72 times 1/8, or 1/8 of 72. So you're just doing 72 divided by 8. There must be 9 red marbles. What else have we got for us? Same thing. Chocolate. Yeah, so that's just the same thing, okay? Probability you'll generally find is a nice way of them wrapping up fraction of amount questions for you. So you should be absolutely fine. There's not going to be that many questions on this particular video. So I'm going to jump to the next one, which is 353, probability of an event not happening. Now, I've also kind of alluded to this right here. On this particular one, if the probability of a red was 1/8, then the probability that it wasn't a red was 1 minus an eighth, so 7/8. If the probability of flipping a coin and getting a heads is a half, well, the probability that I don't get a heads must be a half, because it all has to add up to 1. We can formally write it down as the probability of it not happening is 1 minus the probability that it happens, which is pretty much what I've just said. So this one, you'll probably get more questions here. So there you go, going back to the deck of cards. A single card is drawn at random from a 52 card deck. Work out the probability of a club. Well, we already know that. If the probability of a spade is 1/4, it does say in its simplest form, so 1/4, then the probability that it's not a club is everything else, so 3/4. Let's skim along, see what else we've got. So decimal odds now. So we've only worked with fractions so far, but you will get percentages, you will get decimals, and it changes absolutely nothing. So there's important concepts here that's going to be new to us in this question. When you flip a biased coin, biased is a really important word in probability, okay? Opposite of fair, okay? So not what you would expect. A coin has two faces, heads and tails usually. Now if it's a fair coin, they will be equally likely to happen. So half of the time it should be heads, half of the time it should be tails. Now I won't go into the hows and whys, but you can get biased coins, or you can make biased spinners, have biased dice. So if the probability on this one, it says the probability of tails is 0.44, then even though we've got decimalized odds, the method doesn't change here, okay? Probability that something doesn't happen is 1 minus the probability that it does happen. So if the probability of tails is 0.44, the probability of not tails, or in this case heads, is 1 minus that. If it really does help you with decimal addition and subtraction, think of pence, pounds and pence. £1 take away 44p. You're going to have 56p left, okay? So the probability on this one of a head not being tails is 0.56. Let's skim along. Oh, we get some nasty stuff on this one. Okay, I've flipped my paper now. So the probability that Paul wins a raffle is given by the expression. So we're going to go a bit algebraically here. So this one really, I hope you've been tuning in this long. This could be a pretty nasty question. The probability that Paul wins, let's write it down, is given by the expression G over F. Write down an expression in the form of a combined single fraction for the probability that Paul does not win. That looks really complicated, but hopefully I'll run you through a couple of these examples and you might hopefully see it's a lot of jargon for what is inevitably quite a simple thing. If you think back to what we've just said here, the probability that something doesn't happen, which is what it's asking for, is 1 minus the probability that it does happen. So let's write that down first. So the probability that he loses then is 1 minus the probability that he does win. 1 minus G over F. So that will get you 1 mark on an exam, okay? We've started it, we're halfway there, but clearly it's wanting us to combine it all together. Now what we can do here, if you think about it, this is the important bit. Anything divided by itself is 1. Well, since we're talking in terms of something over F, I'm going to turn this 1 into F over F. Anything divided by itself is 1 minus G over F. Okay, all I've done is change what it looks like by manipulating it using some mathematical rules. Okay, but what I can now do is combine this. I have F over F minus G over F. If I wrote down 3/4 minus 2/4, because the denominators are the same, I can just go, well, 3 minus 2 is 1 of those quarters. So even though we've got algebra on the bottom here, which makes this horrendous, it's still the same. My answer here is F minus G over F. And that would be an expression in the form of a combined single fraction for the probability that Paul does not win. Admittedly, it's awful, but you know, your higher students, we can give this one a try. So that's exactly the same on that one, so I'll skim through it. This one says the probability that Nick wins a raffle is T over U. Work out the probability that he doesn't win in this form. Well, it'd be 1 minus T over U. and then because our denominator is u, we would turn the 1 into u over u minus the t over u. So our final answer will be u minus t over u. And that's all that is. Let's give ourselves a really nasty one, lovely nasty one there. So I'll spin this round so you can see it. The probability that Gordon wins a raffle, and if you can handle this one, you have got absolute top-end algebra, and we are winning. You're going to do amazing come September. Sorry, I'm losing my voice a little bit here. So the probability that Gordon wins a raffle is given by the expression n over n plus 4. Write down an expression in the form, same thing again, in the form of a combined single fraction that he doesn't win. So the probability that he loses, well, even though this denominator is a lot nastier now, well, let's stick to the same method. Let's not let ourselves get scared by an apparent increase of difficulty. It's the same method. 1 minus n over n plus 4. Okay, well, what we did last time was, there we go. Nope, it was there we go, was we turned the 1 into whatever the denominator was on the other fraction over itself. So we're going to do the same here. Instead of 1, I'm going to write the denominator, n plus 4 over n plus 4. That is equivalent to 1, because it's the numerator divided by the denominator, and they're the same, so it's equivalent to 1. Minus n over n plus 4. Well, again, we have the same denominator on both of these fractions, so it's as simple as n plus 4 minus n. Well, n minus n is nothing, so we're left with 4 over n plus 4. Now, if you can do that one, I'm going to be massively, massively impressed. That's some nasty algebra for the year group that this video is aimed at. But that's pretty much the toughest part of this. I will briefly, I'll briefly go over the last video that I'm going to set you, which is video 354. So I'm running out of paper here. Let's get some spare paper in. So video 354. The probability, we're not loaded it up yet, there we go, mutually exclusive events. Now this is a really, really important one for you to read and listen to the video. Watch and listen to the video first, please, so that you really do get a feel of what we mean by mutually exclusive events. This is events that happen regardless of another event happening. So the probability that I wake up late in the morning and the probability that I get to school on time, they are kind of intrinsically linked together. If I'm late in getting up, then that's going to have an impact on the probability that I get to school on time. Whereas the probability that it is sunny tomorrow and the probability that I wake up late, they are exclusive. They don't rely on each other. So if we look at question 1 here, it's just some true and false stuff that you're going to get asked first. True or false, the following events are mutually exclusive. Getting an odd number and a 5 from rolling a fair dice. What you've got to ask yourself is, can these two things happen independent of each other? Is getting an odd number, of which 5 is that an influence or separate? So it's not, so that would be false. If we skip through here, and this is crept in there, this is dead simple, this one. A bag contains only red, green, brown and yellow. It's giving us the probability of red, green and yellow, and they all add up to 0.9. 0.1 add 0.4 add 0.4 is 0.9. Find the probability of selecting a brown marble, that'd be 0.1. Moving on. Simples. Okay, nice algebraic one, that's pretty cool. Bag contains only red, green, brown and yellow marbles. The probabilities of selecting each colour are shown below. Find the probability of selecting a green marble. It would appear that the probability is 2x, but it's out of what? Think about what all these add up to. 2x, add 3x, add 5x, add x. It's 11x, so 2x out of 11x. You can simplify that down, 2 out of 11. And that's it. That actually seems a lot more of an easier video than I was expecting it to be. But definitely watch. It's a 10-minute video on this one, so do try and watch that one, please. And that should put us in very good stead. And I'll leave that with you. I'm only sending you those 4 this week. As As I say, you will hopefully have a live lesson coming up, but due to the timetables and schedules, it will likely be Mr. Warnes that has to deliver that one. So I'll keep him up to speed with how well you're getting in on this. Do message me though if you get stuck. Have a nice day.